In these next few examples, we have to write the equation of a curve after it's undergone a transformation. So the curve that we're dealing with is the curve of y equals 2x squared plus 3x plus 1. In the first part of the example, it tells us that this curve is translated 3 units rightwards parallel to the x-axis. So what that means in function notation is that our original curve, f of x, gets replaced by f upon x minus 3. So remember, if it goes right, but it's to do with the x-axis, it really means minus 3 in our function notation. It's always opposite way around than we think is natural. So what we need to do in our equation is replace all of the x's, so it's changed from a function f of x to a function of f of x minus 3. So anywhere there's an x, it must be replaced by x minus 3. So if we work through the algebra of this, as you can see in this line, I have replaced each x with an x minus 3. So we've got 2 upon x minus 3 squared plus 3 upon x minus 3 plus 1. From here on out, it's just basic algebra. Multiply out those double brackets, expand brackets, simplify, collect like terms. So we just follow through the next few lines of working out, and we should end up with the equation of a curve, once it's completely simplified, to be y equals 2x squared minus 9x plus. In the second part of this example, we have to write down the equation of the curve once it's been transformed by a stretch with scale factor 2 parallel to the y-axis. So using our general function notation, if we start with our original function y equals f of x, to stretch it parallel to the y-axis, we must multiply the full function by the scale factor, which is 2. So all we have to do here is take our original equation and times the whole thing through by 2. So we get y equals 2 upon 2x squared plus 3x plus 1. And again, multiply out the bracket and simplify if possible. And we get our final equation to be y equals 4x squared plus 6x plus 2. So in our third example, again it's a stretch, so we're going to be multiplying something. And the scale factor is 2, but this time it is parallel to the x-axis. So remember, if it's parallel to the x-axis, the scale factor is 2, you want to multiply by its reciprocal, so you're going to be multiplying by a half. So if we have a look, write it in function notation again first. I always find it useful. If you want to leave that stage out, you can. So y equals f of x gets transformed to y equals f of a half x. So you multiply the x's, not by the scale factor, but by its reciprocal. So everywhere in the equation where you see an x, you must replace it with a half x, which is what I've done in this next line. So all x's get replaced by a half x, or I've put them as x over 2, just to make the working out slightly easier. Now we need to multiply this out, so square the brackets, so you end up with x squared over 4, multiply out brackets and simplify. And we should end up with the final answers, y equals x squared over 2 plus 3x over 2 plus 1. Or if you prefer, y equals a half x squared plus 3 over 2x plus 1. Whatever way you want to write it, it's up to you. Okay, in part 4, we're looking at reflecting our curve in the x-axis. So remember, again, general function notation, reflection in the x-axis, the original function, f of x, gets transformed to minus f of x. So all we need to do is take the original equation and times the whole thing through by a minus 1. And once we do that, we should get minus 2x squared minus 3x minus 1. Okay, a reflection in the y-axis then for part 5. So the original function f of x gets changed to f of minus x. So everywhere you see an x in the equation, replace it with a minus x. So if we do that, as you can see in this line of working out, that's what I've done. X has become minus x's again. Square brackets, multiply through by brackets, and simplify terms. So you get y equals 2x squared minus 3x plus 1 to be the function after it's been reflected in the y-axis. Okay, our final example then is where we've got to write down the equation of the curve after it's gone through a stretch, scale factor of a third, parallel to the x-axis. So remember general function notation again. So if we have our general function f of x and we want to do a stretch parallel to the x-axis, then normally it would be y equals a of x, where a is the reciprocal of the scale factor. So because our scale factor is a third, we want to multiply the x's by the reciprocal, which is a 3. So in general terms, it would be y equals f of 3x. Now all we need to do then is take our original equation and replace all the x terms with a 3x. So you can see that in this line of working out, wherever we had an x, it got replaced by a 3x. So same as previously, we just need to expand and simplify really. If we do that, we end up with y equals 18x squared plus 9x plus 1. So you can see there's quite a lot of different ways I can ask a question on transforming curves. You can be asked to draw it, explain it, write down an equation, or occasionally they may give you an equation of an original curve, one of a transformed curve, and ask you to explain the transformation. So just make sure you learn the table off by heart so you know the general function notation for all the different types of transformations.